first lecture from chapter number 8. Today we'll solve the last topic from chapter number 8, that is BiCMOS NAND and BiCMOS NOR. We'll start with a small recap where we know that our CMOS, that our BiCMOS can be in general represented as a combination of a CMOS driver circuit and two BJT transistors. They both are of N, P, N type. The output high voltage is transferred through Q1 from its base to emitter, and the output low is facilitated by this transistor Q2. And in our last lecture, we have studied an example using BiCMOS NOR. In this lecture, we'll draw BiCMOS NAND 2 and BiCMOS NOR 2. Right. Let's first study BiCMOS NAND 2. We know we studied in our last lecture 820 that the formula or the technique to draw a BiCMOS circuit is this, that we draw the regular PMOS array first. This is the regular PMOS array of an N2, and then we draw its regular NMOS array here, whereas the output from the PMOS is used to drive Q1 and the output from NMOS is connected to the output. Right, and then we repeat the same array here. The same NMOS array is repeated, R-E-P. It is repeated exactly as it is here, as it is in regular CMOS. It's repeated here. And then we always have this controlling transistor, which is always NMOS, whose gate is connected to the output from the PMOS array, and its drain is connected to the Q2 transistor. It's always the same, and from the combination of Q1 and Q2, from the common terminals of Q1 and Q2, from the emitter and from the collector, from the emitter of Q1 and from the collector of Q2, we get the output. So I repeat, the NMOS, the PMOS array is drawn as such. NMOS array is drawn here as such, as it is in regular CMOS. The NMOS array is repeated once again here. We have this controlling transistors, and whose input, the gate input, is from the output of PMOS array. The drain of this controlling transistor is connected to the base of Q2, and the output from the PMOS array is connected to the base of Q1, and the output from the NMOS array is connected to the output. Right, we can use this circuit to verify the truth table, TT, truth table of NAND 2. You know that once we have this as 0, this as 0, the output should be a 1. We can verify that, and it's actually a homework for the students. If it is 0, if you have a 0 here, a 0 here, this array will be on and we'll have a VDD here, a VDD here, and here we'll have this base emitter junction subtracted out of VDD, and the output would be VDD minus VBE, slightly lesser than VDD. So V output high would be VDD minus VBE, slightly smaller than VDD. And you can verify it. You can verify it for other options. Let's move on to the next slide, where I have drawn a schematic for BiCMOS NOR 2. So we adopt the same policy. The PMOS array is drawn. The PMOS array of regular CMOS is drawn here. The NMOS array is drawn here. The NMOS array is repeated here with the same inputs, and this is the controlling transistor like we always have, which is connected to the output of the PMOS array, and the Output of the PMOS array is connected to the base of Q1, and the drain of this controlling transistor is connected to the base of the second NPN transistor Q2, and the output from the NMOS array is connected to the output. Here is a small homework for my students. You have to verify this trust table for these 4 different options that we can have, this 1 or 2, and you should be ready to now should be able you should be able to draw schematic BiCMOS schematic for any Boolean expression. This is very important. Now, after we have studied everything regarding BiCMOS, you should be able to draw schematic for any given Boolean expression. We will try to solve an example related to BiCMOS in the next lecture. That will hopefully be our last lecture from chapter number 8. Thank you.